You need to have your notes out for Lecture 4 on relative frequency charts. All right, so start off with the definition. And this is the definition of descriptive statistics. And I'm not going to write it all here. I'm just going to say what it is. And I don't want to write it all because I'm just going to take up too much room. Descriptive statistics really amounts to a set of procedures or things that we do that will help us describe or summarize a set of data. So we use them to summarize a data set. What's a data set for our purposes is just kind of a set of numbers, maybe a huge set of numbers. Someone dumps a set of numbers on you. What can you tell from that set of numbers? What information can you extract? Well, we want to, right now, just look at some ways we can maybe summarize the data set. And we're going to, like I say here in the notes, if you see it, we'll consider several ways to do that. Maybe you want to pause me and read the paragraph right before the example there. So pause for a second and read about frequency charts. Okay, so in our example, we have 25 married couples with no children. They were each asked how many phones they had in their household, including landlines, cell phones, all that. And I've listed there the numbers. I'm not going to write them on the board. If you have your notes out there, you can see them. So I got this set of numbers, and it's not very easy to glean much information from them. So what we're going to do is we're going to construct a frequency chart. The first column will be what we call the column for the class, which is the data values we're interested in, which are the number of phones. Next, we'll have the frequencies, all right? And frequency means the number of those data values that particular data value that occurs, all right? If you see that there are some couples who have no phones, believe it or not. So if you go through that data set, you discover there is one. Right? You kind of mark it through, so you've got it taken care of. So there's one. The class 0 has one frequency. What about couples who have only one phone? If you go through the data set, you will find a frequency of 5. There are 5 couples that have just one phone. For 2, there are, 7. For 3, there are 11, and there's actually one couple that has 4 phones, and I think that accounts for all of the 25 in our data set. These are the data values, and these are their frequencies. All right, so I already get a little bit more of a picture, right? I can see that the most common number of phones is 3, right? Followed by 2 and then 1, and it's pretty unusual to have no phone, and it's unusual also to have 4 phones. So I already get a little bit of information here it's a little easier to see it from the chart than it is from looking at the data set. Okay, this is a very easy example of how we might summarize this set of data. There's a third column, you'll notice, and that column we call the cumulative frequency. What is the cumulative frequency? It is the frequency of the particular class at which you're looking at together with all the classes below it. So in other words, the very first class with the data value of 0 has a cumulative frequency of 1. The next class has a cumulative frequency of 5 plus 1, which is 6. The next one has a cumulative frequency of 7 plus 5 plus 1, or I can just think 7 plus 6, and that gives me 13. The next one, I just add 11 on here and get 24, and the next one I add 1 on and get 25. So you can see what the cumulative frequency gives me for, like, say, the value 3 is it tells me how many married couples have 3 or fewer phones, right? For 2, it tells me how many have 2 or fewer phones, all right? And that's something that's used quite a bit in statistics. We won't use it a lot, actually. The more important thing we're going to look at is the fourth column I have there, which is the relative frequency. What's the relative frequency? Again, I'm not writing a lot of this out just because I want to be sure I have enough room, but in your notes you're asked to write out what the relative frequency is. And what that is it's the proportion of that class in the whole data set. All right, so in other words, it is the frequency of a class divided by the total number of data points. So for relative frequency, and what I might do is draw some horizontal bars here so that we keep things nice and separated. Okay, relative frequency for the class of 0 is 1 divided by, the total is 25, right? Total number is 25. So I have 1 over 25, which is 0.04. For the class of 1, the couples who have just one phone, the frequency is 5, and I divide that by 25, and that gives me 0.2. For 2, it's 7 over 25, which is 0.28. For 3 phones, it's 11 over 25, which is 0.44. And for 4 phones, it's 1 over 25, which is 0.04. So what each of these is the fraction of the total number of couples that have that particular number of phones, right? So if we add them all up over here, if you add them all up in this column, you should get 1. All right, just like if you add up the frequencies, you should get 25, and what are you doing? You're dividing each one here by 25. So you divide the whole 25 by 25, and you should get 1. You should always get 1 in your relative frequency column if you add them all up. All right, let's see. In fact, what I want to stress is that what we really want to get out of this, like I said, we won't use cumulative frequency that much, and really, usually when we use frequency, we're using it to get to relative frequency. So what you want to do is you want to think more of the above as a relative frequency chart. The most useful column, of course, we'll need to know the class values, but then the most useful column over here will be the relative frequency. So it's really more like a relative frequency chart. What I want to do now is summarize that data graphically, which will give us even kind of a better picture of the data set, I think. Along the horizontal axis, I will have the classes, which are the numerical values, right? We can have 0 phones, 1, 2, 3, or 4. So I have here 0, and let me put 1 about there, 2 about there, 3 about there, and 4 there. And the vertical axis will be the relative frequencies. I'm going to abbreviate, all right? So this is the relative frequency. Well, it's a bar graph, but it's a special kind of bar graph. When we put the classes along the horizontal axis and relative frequencies along the vertical, we call it the relative frequency histogram. And what I'm going to do is at each data point, I'm going to draw in a bar, the height of which will represent the relative frequency. Okay, so I'm obviously going to have a much different scale on the vertical axis than I have on the horizontal axis, and that's fine. So let me put maybe about right here. Here's 0, right? So let me put let's see, 0.04, maybe about right there. Okay. Then if I draw this bar in, I'm going to go ahead and draw it in. I want to draw it in so that the bars all touch. So I will draw this over to about the halfway point, and so it has to go back about that far. There's the first bar. The next bar for 1 will be centered over 1, and it'll go from here to here, halfway between 1 and 2 over here, and it has to go up 0.2, which is, of course, 5 times this one. So, 1, 2, 3, 4, 5, maybe about that height. So it comes over and looks about like that. Okay. Then I got to go up to, for number 2, I got to go up to 0.28, which is 7 times that. Is this about right? 1, 2, 3, 4, 5. It's a little bit tall probably, but I'm not going to worry about it too much. So I got to go up about 2 more of these and over to there and down. And I should be labeling these. So this is, this is 0.04. This is 0.2. This one here is 0.28. Okay, to go up to 0.44, well, I've got to go up another, about 4 more of these, right? So maybe about 2 of these, so 1, 2, maybe about right there. So it'd be over here maybe. That's 0.44, and that's probably a little tall. Gotta bring it down a little. 0.44. And I go over to halfway between 3 and 4, and down. And then lastly, 4, I'm back up just to 0.04. And over. Okay, so as far as the histogram, well, notice how we do sort of get maybe a little bit more of an easy to comprehend visual image of the data. Right, it goes up, 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 and then drops off, right? And 3 is the one that's biggest, as we saw before. The notes on this histogram, I guess I want to point out 2 things. The bars touch. You always want the bars to touch. You don't want spaces between them. Let's see. I guess each bar is centered over the class value for it, right? So the bar for 2 is centered right over 2. It's supposed to be centered. It's off a little, but the bar for 2 is right above 2. It has 2 right in the middle of it. What else? I guess the other thing to notice here, this is a discrete data set, right? When I have a discrete data set, I have a single data value and a bar above it. In this case, the total area of all the bars, notice that the height of each bar is in each case, it's the value over here, which I'll sum to 1. But what's the width of each bar? It's just 1 unit, isn't it? The way I've drawn them, they all have they're 1 unit wide, so the area is 1 times the height. So really, I'm just going to take the height times 1 all the way through to get the areas. So the total area is the same as the total of all these numbers. I'm just multiplying each one by 1. So the total area of all bars equals 1. And this is something we will come back to over and over again. All right, let's see. I guess I want to say a little bit here about, where can I do this? Maybe just want to say a little bit about relative frequency. A little bit more, I guess. All right. In the event that I might have to kind of interweave here, let me change colors. Now, the big thing I guess I want to say is, again, I'm going to abbreviate, the relative frequency of a data value is also called the data value's empirical probability. Empirical probability. Okay, haven't even really defined what we mean by probability yet. I just want to say that I think that you have this intuitive notion that what the probability of a number means is how likely is that number to turn up in the data set, right? So you can see that if, for instance, the relative frequency of 3 is 0.44, what I'm saying is that 0.44 or 44% of the data values have the value 3. I'm saying that the empirical probability that if you grab a couple at random out of this set of 25, the empirical probability that they'll have 3 cell phones is going to be 44%. Right? So it represents the likelihood, which is represented by the proportion of that data value occurring in the whole data set. So for instance, let me just ask you a couple questions here and have you pause and try them. Question 1, what is the empirical probability that let's see, I guess I want to do, that a couple has 1 phone and question 2, if I can fit it in here, I want the empirical probability a couple has more than 2 phones. All right, so why don't you pause and see if you can figure that out, and then I'll answer it. So give a pause. All right. Empirical probability that the couple has 1 phone, it's the same as the relative frequency of 1. So I come back over here to the histogram, and I see that this has area 0.2, right? 1 by 0.2, or I can just go over here to the relative frequency chart and see that it's 0.2. So the answer is 0.2. 0.2. Empirical probability a couple has more than 2 phones. What I need to do there is think to myself, what does more than 2 phones mean? In this context, more than 2 phones means 3 or 4. So naturally, I'm going to come over either to the relative frequency chart and look at these relative frequencies and add them up, or I'm going to come back over to the histogram and say, okay, more than 2, I'm over here. I'm going to add up the area that I have right here. And either way, I'm going to get the same answer. I'm going to get 0.44 times 0.04, so it's 0.44 plus 0.04 is 0.48. Okay, hope that makes sense.